Hello, you're welcome to my channel. My name is Loange, and in this video we just want to make sense out of the definition we gave on the dot product or the scalar product of two vectors. Okay, I promise to just make sense out of it, kind of like a verification. Okay, now I stated that some teachers do make this, bring up this result, okay, like bring this up as a result, okay, or like a theorem. So we just want to kind of verify it as well. All right, good. Okay, so we have that the directions of these two vectors are inclined at an angle, and we call that angle theta. So you want to see how the dot product of these two vectors is given by the product of their length. So I'm using A times B simply as the length of vector A, as the product of the length of vector A and B, and then we multiply that by cosine of theta. So let's see how we can make sense out of that. Okay, great. So let's say we have vector A pointing in this direction, then we have vector V pointing in that direction. So I want to think about a new vector, and this new vector should go from maybe point A to B. It doesn't matter. You could also think about yours as going from the terminal point of vector B to the initial point of vector A. So I choose to do that from the terminal point of vector A to the terminal point of vector B. Okay, great. So what is this vector? What would this vector be? Well, just want to think about it as this way. Let's say you want to add vector A to something so that you get vector B. That thing should be vector B minus vector A. Okay, you could say, how did I get there? Well, this is it. This is the idea. To get there, this is what you may do. You have to, first of all, withdraw vector B, knowing that the position of a vector is immaterial. What matters is the direction of that vector and the size of the vector. So that is like good enough to be called our vector B, right? So if that is vector B, then we negate vector A. In other words, we draw a vector which is the same size, which has the same size as vector A, but opposite direction. All right, opposite direction. That means it's going to be pointing in this direction. So this is negative of vector A, while this is our vector B. Okay, so you can see if you take the sum of these two vectors, vector starting from here to here plus vector from here to here, it connects from there to there. All right, this simply means the sum of vector B with negative vector A. That is, if you take that sum, that is what you get. All right, that's how we can make sense out of it to get into getting that. That was how I was able to see that. Or you could simply say you want to get vector B from vector A. So you just say vector A plus B minus A. It will give us B, right, without having to draw anything. Okay, great. So that is it. Now the next thing I'll do is to use law of cosine. Now law of cosine on the length. So I'll just write it down. Sorry, let me not use blue. Let me use white for that. So we say law of cosine. Law of cosine. All right, good. So we know that this is the opposite. So I'll say the length of that side containing this difference. The square of that length is the following. That will be the square of the length of vector A plus the square of the length of vector B, okay, minus 2 times the following length, vector A times the length of vector B, all right, times cosine of theta. Okay, great. That's from the law of cosine. Now recall that from one of the properties of vector dot product, that if you take the dot product of a vector with itself, is something as taking the square of the length of that vector. So since this is the square of the length of this vector, we must have gotten it from the dot product of this vector with itself. That is the dot product B minus vector A dotted with itself. That's how you're able to get this length. And then on the right hand side, we could do the same thing. Just simply take the dot product of vector A with itself, that is A dot A, to be this. All right, I hope you record that property, B dot B. So if you haven't learned that, then you may have to go back to our previous videos to check that out, right? And if this is the first time or you've not subscribed to my channel, please don't forget to do that. Subscribe to my channel, share the video with your friends, of course, when you find it helpful. Okay, so we have this to be vector. Just put down these other ones. So what did I do there? What I just did there was to rewrite this as the dot product of vector with itself. We were able to see that in one of the properties, which was from our last video. So let's distribute this. So when we distribute that as vector b dot itself, that's b dot b. Okay, then minus, we can easily see that to be minus 2a dot b. So that is b dot b, then you multiply that as minus a dot b, then minus a dot b, that's minus 2a dot b, then plus the vector a dot a with itself. That's just by distributing the left hand side, and then I'll still write down the right hand side, that is the following. Alright, great. Now you notice that we'll cancel the following. We can cancel this with that, and then cancel that with that. So we're left with, after cancelling that, we are left with negative 2, then the dot product of vector a and b to be the same thing as negative 2 of their length. So please permit me to just write ab to denote the length, right? Yeah, cosine theta. Of course, again, we can cancel this and that. Negative 2 cancels out with itself. That's by dividing both sides by negative 2. We are now left with the dot product of vector a and b as the length, that is the product of their length times cosine of theta, which is the desired result. That's what we wanted just by rewriting this. I hope that's clear enough. All right, so maybe I've made everyone happy now, isn't it? Okay, I hope you enjoyed the video. Please don't forget to subscribe to my channel, share the video with your friends, and we'll continue from our next video.